In this lesson, we will look at the proof of the Pythagorean theorem. You're looking at a visual of the page that I've developed for you from the text. There is a more formal proof here using the diagram to prove the Pythagorean theorem, and that is what we call a squared plus b squared equals c squared. But really, there's much more to it than that, and that is if you take the two legs of a right triangle, square their lengths, is always equivalent. The sum of that is always equivalent to the square of the hypotenuse. I wanted you to examine this at the bottom of the page, and I'm wondering if anybody figured anything out about it. Okay, so if I move this slider, notice that these pieces move over, and then that's all there is to it. You might be wondering what is going on right here. What is really being asked? So what I hope you notice is that there is a big square. Okay, there's a big square right there, and when I move the slider, I get two little squares. Well, what we're trying to determine is this big square has lengths c. Okay, c by c. Okay, in other words, the area of that square, the area of a square, in this case, is c times c, or c squared. All right, but when we move the slider, we notice something different. All right, it rearranges when I move those pink triangles to two smaller squares. The yellow space is still the same value, but it's two smaller squares. And notice that its length is now determined by the lengths of the right triangle, right? This little length is A. This is a different leg, B. So this square over here is B by B. This little square is A by A. So we have a different area, right? But it's still the same yellow area, but it's defined differently. It's made from an A squared to A times A, right? That's this region here. And then it's also a b times b, which is a b squared, and it's the sum of those two. So it's a pretty cool proof of that.